Hello there and welcome to the new Python case study or Python project where we will be evaluating the diabetic patient's data and basically going to predict that based on the given variables whether we can identify someone is diabetic or not. So think about this diabetes is a very common problem, and if you can, let's say, create a model by which you can easily predict whether someone is diabetic or not, can be good. Also, it can be advanced to what are those early signs which basically can identify someone is diabetic or not. However, this is completely out of scope because the data set we have is only about the diabetic patient or non-diabetic patient. Also, you can think about, you can create a website which can basically allows user to enter certain parameters, and then with this you can basically identify whether someone is diabetic or not. So this can act as a general application on which a website can be built, or it can work as a general software that can be sold to, let's say, to the medical these hospitals or the laboratories which are doing tests. I'm pretty sure that by this time probably they will be having this, but if not, can be an amazing opportunity. But this project is basically to learn and understand how you can do these type of predictions, basically build multiple models, which I have shown it over here, and then get the most out of it. So we have these 15 different questions about starting from importing the data set, checking whether it has null values or not, how many rows and columns are present just to get just about the data set, checking each column data type, what data type it has, generating statistics for each column, like what is the mean, average, or this median, or these different percentile values that you have, checking the data imbalance by visualizing it, exploring each variable and identify the shape and outliers, scatter plot for each variable to visualize relationship, correlation table, visualizing the correlation, get an idea how the target variable is different for each column, just a high level idea before we start doing the machine learning. And then here machine learning basically starts with the creation of x and y variable. Then we split the data set, which is a common practice for any machine learning project, where you divide it in the training data set and testing, so that you can train the model and check the validity on the testing data. And then we have these different models like logistic regression, decision tree I will show you, random forest, SVM, XGBoost, all of these different models I will show you how you can run it and find their accuracy, classification report, and confusion metric. That is further to do the interpretation of data and get the most out of it as to how do you want to get the results out from these different models. And then finally find the variables that impact the most. Generally a very common question which users ask about what are those variables which impact the most, or which impact the most the model, right? So is it like one variable which is impacting the most, or two variable which is impacting the most, or let's say completely opposite, which variables impact the least? Probably you can even think about that if we can remove those, then whether this can improve the model accuracy or not. So that's something very interesting that you can find in this case study or project. So overall, this will going to be pretty much end-to-end project, which I will show you step by step. And here's the file, the diabetes file. And if you would have observed by now, I'm using the Google Collab, which is collab.research.google.com. It is the online, as you can see, the Python notebook. As you can see, the notebook sign is there, IPYNB. The reason I'm using this is because sharing it with you is very easy. You can simply find the link of this notebook in the description along with the dataset link, so that you can get both of these things easily and practice it once, let's say, you have gone through this video, or if you want to do it side by side, that's also okay. So first thing first is, what I have done is I have uploaded the data by using this link or using this button, which is basically saying that upload to session storage. That means for this session you upload this data. Once the session is out, the file will be removed, right? So if you are trying to run this file again, you may need to upload this file again. All right. So first thing first, we will going to import the libraries, and don't worry, I will not import all the libraries at once. I will import the library once the requirement is there. So you will know that when a particular library needs, you need based on the requirement. All right. So first thing first, import pandas as PD, because we need to import the dataset and we can need to run many dataset related operations. So first thing is importing the pandas and importing numpy as np, because some of the operations may require numpy library. So two very standard libraries. If we want, we can import, let's say, matplotlib as well. So matplotlib is the visualization library. So we will going, since we have some step for visualization, so import matplotlib.pyplot as plt, and I will import one more library, visualization library, import cborn as sns, which is also helpful in the visualization. So at least for the point number 11, we have imported the library. Everything which is related to the machine learning, that is from step number 12 to step number 15, is something which I have left it, and I will use it or I will import whenever the need is there. So if I execute, you will see that an execution is happening, and now it's pretty much done as it is completing. Okay, so it took 4 seconds. All right. Now, after this is done, the next thing is importing the data. So I will use the same, I will create this object data and use the pandas pd.read_csv, and that will be diabetes. I think the spelling should be same, diabetes.csv. So if I execute, you will see an error. All right, no such file or directory. Like I said, this should not have an error. So not DAI but DIA, and execute. So now it is executed. So let's review first few rows, and even I can say prior to this that before I check the null values, or let's check the null values. To check the null values, the command you need to write is data dot is NA, whether it has a null value, dot sum. So once you execute it, you will going to see each variable and whether it has any null value or not, right? So no column has the null value, and nothing can be better than this. However, real life situation will be very, very different. You will face many issues on this step. So probably in a different data set, when we'll have a situation like this, we'll tackle that. Okay, so first thing first, now what I can do is I can just check a couple of rows for you by using the operation data.head, and this will going to give us the first 5 rows. This is the index starting from 0 going all the way to 4, right? If you want to access any row, you can simply say data 0 and you will going to get that particular row for you. Oops, okay. Looks like I missed the iLock, and this will now give us the first row value. So pregnancy 6 is what you have, 6, glucose 148, you have 148, blood pressure 72, skin thickness 35, so on and so forth. So just wanted to show you a different operation through which, if you want 5 rows or if you want any specific row, using the index, how you can fetch this. So that's what we wanted to get. Now check how many rows and columns are present in the dataset. Okay, let's do that. Data.shape. Simply by this, it will going to tell us that you have 768 rows and 9 columns, right? Now after that, how many rows and columns you get to know. Check each column data type. Okay, so what do you need is info, data.info, and parenthesis. It will going to give you each variable, as you can see, and this is all integer. BMI is float, that means it is also numeric. This is also numeric, but this will give you a good idea. Let's say if you are expecting something to be an integer but it is not, then in that case you can convert it into an integer one, or let's say from a float, for example, in this case. So we have got this up until here. Also, let's say for any reason, if you just want to get the name of the columns, then you can use this command. This is just additional stuff I'm telling you, data.columns, and this will going to give you all the column names. Let's say you want to get all the columns names, so instead of writing one by one, you just get this entire list and you are done, right? So this is an additional stuff I wanted to tell you, and I'll keep telling you all of this thing other than the question I have put it here as soon as I will feel that this is something can be useful for you. Also, this can be interview questions. Consider each command here as interview question as to how you can access a specific row by index. So this is the command you may need to tell. Also, how would you check the missing value for each column? Then this is the command that you will need to basically tell them, right? So now let's move on to our next step. Generate statistic for each column. This you can do this using the describe command. Once you say data.describe, here you will have a beautiful table. On the top you have columns, and here you have the count, the standard, the mean, the standard deviation, the minimum value, the maximum value, and then 25th percentile, 15th percentile, which is also median, and 70th percentile value. This basically helps us looking into the data a little bit more in depth as to minimum value is 0 and 15. Similarly, if you see BMI value, minimum value is 0 and maximum value is 16, which says to me that this minimum value for BMI cannot be 0 in any case, if I'm not wrong. So these type of statistic can help you quickly interpret. Also, if you see this median 3 and mean is 3.8, as you would know if you have done the statistics course, that mean is influenced by the extreme value either on upper side or lower side. So you will see in most cases that value is different from mean. However, it should not be very different, right? Like 3 to 3.8 is fine, but if it is 3 and this is 10, that means something is really wrong. So this table basically explains a lot about what statistics is and how you can interpret the different statistics and get the most out of it. All right, so after that, generate statistics for each column, check the data imbalance. So basically this is about on the target variable as to how many variables, for example here in this case data outcome, how many variables are present. So data outcome dot value underscore counts, right? And what it will give you is how many values 0 non-diabetic has and 1 which is diabetic has. Now in this case the diabetic values are half of what the non-diabetic values are. That means your data set, or there is a good chance that your predictions may be a little bit more influenced by these observations, non-diabetic one. That means there is a diabetic person, but our model is predicting that it is a non-diabetic. And in that case, we may need to properly validate the data by taking a lot of test data set and giving them some sensitive values and seeing whether it is giving us the good output or not. So this is for your information, but it is very important that we see this. But in this case, this is very easy. But if, let's say, for some reasons you are not able to interpret this, that what is the percentage of values here and what is the percentage here, then what will you do? So this can be an interview question as well. So what you need to do in this case is you need to come here and simply say normalize equals to true. And once you do that, it will give you the percentage. That means Non-diabetic, you have 65% of the values. Diabetic, you have 34% or almost like 35% values. That basically gives you an absolute value, or probably your end user or your management would be looking as to what we are dealing with or what data set we are dealing with, right? Now, what if you need to visualize along with this? So the way you will going to do this, I'm going to use the Seaborn libraries, SNS, and I will use the count plot to count these values, where my X variable is the outcome and my data is data. That's a simple thing what we need to provide, this outcome variable name and the data. Once we do that, what do we get as an output is a simple bar plot, which basically helps us visualize all of this information we have just plotted it over here. So as you can see, we have outcome 0 and 1. 0 has more values, 1 has less value, and almost like half, right? But this percentage can basically make it completely clear as to what we are, what exactly is there in the data set. So that's one thing which basically you need to do to plot it. But what I want you to do is basically I will show you one other way, which was or one step: explore each variable and identify shape and outlier. So how we can complete this step is by using the histogram and the box plot, right? So basically two figures what we need to plot. So I will going to use the matplotlib library, which I have used here. Import matplotlib as plt, and in combination with the Seaborn library. So this is where things will get little tricky, but keep this code with you or use this code to make your project or your workbook easy in terms of creating these type of outputs. So plt dot figure, I will say I need two figures, and we need plt dot subplot, and subplot is basically what we need is 1 to 1. Basically this will be the first plot. So this what we specify is the 1 to 1, and the way we interpret it is basically first row. It's basically indicate that you have one row, two column, and this will be the first chart. This is what 1 to 1 will going to indicate. Okay, so plt.subplot 1 to 1, sns dot since I said histogram, so we will going to use dist plot or distribution plot, and data, we let's say use one variable, pregnancies, let's say pregnancies. Okay, so this will give us the pregnancies. Now we will say plt dot subplot was first row, one row, two column, second chart. So 1 2 2. So whenever you are writing it, repeat this what I was saying. And here we will going to plot the box plot. So pregnancies dot plot dot box, and we will going to use the figure size of, let's in this case is 15,5. Depends on whatever you want to use, but this is what I'm using. So let me give it. So you get a beautiful output over here. So here you get the pregnancies, and as you can see, values are skewed over here on the left side, and over here you have the pregnancies where you see there are some outliers which is present near to these observations, and it has a longer lag. That means most values are present here. The median value is little bit down there at 2.5. So these pictures or these plots talks a lot. And what you need to do, that like I have done with the pregnancies, do it for glucose, do it for blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age, and see what output you are getting. That way, by the end of this, you will have a complete knowledge that even at the middle of night, someone is asking you to plot this, you will be able to plot this. Forget about interview. You will be able to plot even at the middle of the night. All right. So I hope you will enjoy that. Keep repeating this, and I'm pretty sure by the time you will be reaching to the last variable, you will be doing it even when your eyes are closed. All right. After that, the next thing is create a scatter plot. Okay, we have explored each variable. Create a scatter plot for each variable to visualize relationship. All right, let's do that. And in just one simple command, we will do this. It will going to take a lot since we are using this online version, and sometimes data and bandwidth is a thing. But sns.pairplot and simply specify data. That is it. It will going to take a couple of seconds, like it is showing. But let's see how much time it takes. Generally, based on the number of columns and the number of rows, that means how big the data set is, accordingly it takes time, because every processing is happening online, right? So now you see we got the first notification that okay, access pair grid is coming, and it will going to take also right now as well to take a couple of more seconds. So let's see how much time it takes. That way you will get a real-time idea. Okay, there you go. Right, think about that. For each variable you would have to have plot, if you would have plotted, how much time it would have taken for you. But with the help of this, every variable is now in front of you. You can clearly see this is sort of a relation. Nothing is coming out here. This is also the plot which we plotted. This is the plot which we earlier plotted, if you see this one, right? So it shows almost like nothing specific over here. Little bit of slope like this one, right? And basically, you know, once you will sit with it, you will spend hours interpreting it. And even for doctors who are doctors, they will find some interesting observations. For me, it's like, you know, I just want to show you how you can produce a relationship metric or a pair plot data like this. But what if we want to get the exact correlation values for this? So that, I think, is the next question, if I'm not wrong. There you go. Generate correlation and visualize the correlation. Perfect. Let's go down and see this. So to get the correlation metric, very simple function, data.core, and you are done. This will produce the correlation metric. However, interpreting it and going one by one, like BMI here, okay, weak, slightly high, yeah, little nothing, like weak. So how would you visualize this is something I will show you in the next step. So one thing is viewing the actual number, but this is not helpful if you have these many variables or even more. So what I will say is I will produce the correlation metrics and store the result of data.core. So whatever is the output is coming here is stored in the correlation matrix. Okay, and we will use the heat map from sns.heatmap core underscore matrix cmap equals to, let's use cool warm. You have multiple templates. I'm using cool warm over here. So once we execute this is what you get as an output. So clearly skin thickness and insulin has the correlation with variable here. Diabetes pedigree function, not diabetes, sorry, age has correlation with the thickness, some correlation here, and here you have slightly negative correlation with this. Age and pregnancies, same is coming, age and pregnancies here. So this is an interesting way of visualizing this. But if you want to have little bit more control on this particular metric, then basically you can combine this with the matplotlib. So I will show you another way by which you can you can basically increase this little bit. So plot dot subplots, and fig size is basically, let's take 12,8. It will be a good big size, 12,8. Okay, so plt.subplots, and this is this. And after that, what we need is sns.heatmap, and we need core matrix, very simple like this one. And we use cmap, and in cmap I think Collab. So once we do that, sorry, it has to be plt. So once we do that, what it will give you is basically an output like this. So this one is okay, but this one is better, as you can see, to look at your visualization. And the reason for this is we are setting the figure size like this one for whatever we are plotting here, and that way you get a better picture out of it. So that's something I wanted to show you, how you can basically do that. Now let's move on to the next question, which is get an idea how the target variable is different for each column. Okay, just to get an idea, the command we will going to run is group by, and we will say outcome, and we will use the mean on an average, how it is different for each column. So outcome is non-diabetic, diabetic. So non-diabetic pregnancy value has 3.2, one has 4.8. That means they are significantly different. Similarly, 109, 141 different, 68, 70 somewhat similar, 19 to 22. It may be different. I'm not an expert on this, basically on, maybe doctors can, or those who basically deals with this can talk a little bit high level. But to me, just by looking at it, like insulin 68 and 100, significantly different what I can see. So just to get an idea as to what it is. All right, so now after that, we have understood this. What do we need? Well, we need create an x and y variable for machine learning, right? So x and y variable, x equals to data. So x should basically contains everything here, but not outcome. So we will simply going to drop outcome and store everything else in the column. So data dot drop, and we will say columns equals to outcome, and axis equals to 1. This is what you need to specify, that you need column, so that's why 1, right? And y will be simply your everything, only the outcome. So there you go, you have x and y variables, right? Once you have done that, now you need, basically the second step is splitting x and y into train test data. So here I will import the library from sklearn.model_selection. We will import train test split. Okay, let's execute this. So it will split the train and test data, and now we will going to use x train, x test, y train, y test equals to train test split, first variable x, y, what we created here, and then we need to specify the test size. Let's keep it 0.2. That means 20% of the values should go in the testing on the test data set. And after that, if we want to reproduce this, so we can say random_state equals to 1 to 3. So once we execute, it will create these 4 variables using this function. So 80% of the data is going in the train data set, like x train and y train, and 20% of the data is going in the test. That means x test and y test. Because once you train the data, it is important that you tested on the unseen data. All right. So once you are done with this, you need to then start performing the train test, the modeling, right? Logistic regression, decision trees, so on and so forth. So all of that you need to do it, and for that we will just continue with the model import and running the relevant code. All right, so first thing is the logistic regression, because it is a classification problem. So sklearn dot linear underscore model, you need to import the logistic logistic regression. There you go. I was just asking it to it autocomplete. All right, so once we have done this, we need to define this equals to logistic regression. So logreg dot fit x underscore train comma y underscore train, right? Log. Okay, so this is what it is. Increase the number. All right, let's ignore the warning for now. What do we have after that is we have fit the data, and now let's predict. Logreg underscore predict is equals to, we have this logreg, low battery, crap, logreg dot predict, and for now what I need to specify is basically the test. So x underscore test, and I'll execute it, and here you go. And now what I need is basically I need to get the accuracy scores. So to get the accuracy scores, I will use from sklearn dot metrics import accuracy score. All right, because as accuracy score is something what we need to get it over here, and accuracy score is something we need to specify. Accuracy score, and here we need to get the actual values and the predicted values. So y underscore test is related to the values what we have provided here, and here is the predicted value based on the x test. So this will be logreg underscore predict, this one, right? And what you will going to get is what is basically the accuracy is. So 79.22% accuracy without doing anything is amazing here. So that is something which is basically telling us that this data set is very much clean, balanced, and without performing any standardization or anything. Even we have not done the cross validation. Maybe cross validation can further reduce the result for 3 or 4%, just so that what we get is the absolute correct output. But for now I'm not using the cross validation or standardization, but still 79% is impressive. It's basically saying that if we have out of 100 times 79 times we'll be good, or 79% we can be 79% of the time we'll get the right output. Okay, so once we have this, so we have basically got the accuracy scores and everything, and I think after the accuracy score, what we need is basically the classification report and the confusion metric. So now for this I will again sklearn dot metrics, and I will import the classification underscore report and confusion underscore metrics. Confusion underscore metrics. And what we need is basically we need to get the output for both of these things. So it's actually quite simple. I will use it in one simple command like print confusion underscore matrix. While getting the output is easy, but interpreting it is difficult. So we have y underscore test and log reg underscore predictions predict log reg underscore predict. Okay, so once you do that, you will get the output of this. And similarly, when you will get the classification report, print classification underscore report, same thing you need to apply over there, and log reg underscore predict, where you get the output, where you have precision, recall, F1 score, and support and all. You may need to do little bit of work here, because if I start explaining this will go in a very long way, and this is very use case to use case very different. For example, it has metrics like you have precision, you have sensitivity, you have specificity. So what I suggest is go here, sklearn classification confusion matrix. Okay, and go to this sklearn scikit-learn confusion matrix site, and basically it basically tells about the confusion matrix over here, and what it basically Wikipedia entry for confusion matrix and its parameters. We have already shown the parameters. What I basically wanted to give you is something which can help you learn about the confusion metric. So let's see Wikipedia over here. Yeah, so this can be something useful for you, where you have true positive rate, like I was saying, sensitivity, recall, hit rate, true positive rate. This can be something useful. As you can see, it is a whole topic in itself, right? So I really want you that you go through that. Otherwise it will be, for me, it will take like another 5 hours just to explain this. And similarly, you need to basically learn about classification report. What does F1 support score means, what is recall means, what is precision means, and support means. If you don't know about this, producing the output does not make any sense. So I just wanted to mainly show you how you can produce the output, but interpretation is an altogether different ball game, where probably a separate video is needed, and maybe I'll create that if I let's say get more comments from you. All right. So same thing you need to repeat for each of these models, right? We have run the logistic regression. You need to do the same thing for decision tree, random forest, SVM, and XGBoost, right? And let me check what is my battery status is, just 2%. So let me plug in the battery, and I'll complete this video a little bit later. All right, I have got the charging back, so I can continue now. And so this will going to be these steps that we will going to repeat again. That means initialization of the model, fitting the model, predicting the model, accuracy scores, and everything. So what I will now going to tell you only this thing, that how you will going to import the library, and I want you to run all of these steps and look at the accuracy score. So the next model we will going to do the is the SVM, the scalar vector machine. So the way we will going to import this is from sklearn import SVM, right? And I will just tell you one more line about initialization. So SVM underscore model equals to the way you will going to specify, you need to basically specify the kernel here, and it will be linear for doing this classification. So SVM dot SVC, the way you initialize this model, and X underscore train and Y underscore train is what you will going to specify. And then you will going to repeat all of these same steps which I have mentioned earlier, right? Once you will execute, the model will give an error. Let's see why it is taking it. So, oh sorry, This is not what it is. This needs to behave on the fit svm.svc, and we need to specify the kernel here. I mixed it up with the fit kernel equals to linear. With that, you will get the linear classification. So the model is now initialized. You need to fit the model, predict the model like you have done it over here. We have done this initialization part. So now you need to fit the model, predict the model using the accuracy scores. Since if you have already imported, then just run this function. Also, if you have already imported this, just run this function and get the output, and just compare what is the output you get in logistic regression as compared to the SVM model, which will give you a first initial idea as to whether logistic regression is performing better or whether you are getting the good output from the SVM, the scalar vector machine model. After that, what you can do is you can basically run the next model, which is the random forest classifier, and the way you will going to import that is this sklearn.ensemble and import, and you will say random forest classifier. As you can see, I will again just help you to do that initialization. So we will say RFC random forest classifier, or you can say RFC underscore model, whatever you want to initialize it with, and we will have random forest classifier, the same one which we imported just now, and here we just have to specify the number of estimator. By default it takes 100, but mostly the way we do this is you can take somewhere between like 300 or 400, so I think 300 is good enough. So this will basically going to have the only parameter you need to initialize. If you are not initializing, that's also good, but initializing it with the slightly increasing number of estimator is what it will give you the good output. So let's say 200, so you just initialize that and you get the output. Again, to learn more about this, basically just search here. We have done it earlier in the Google about the sklearn and random forest classifier, because it has a lot of parameters. Again, going in each will have like a 2 hours video. So with that, what you can run here is an additional important thing. So let me just run this. If I run this, the model is run rfc underscore model dot fit. We have to fit it. It will be based on x underscore train and y underscore train, right? And rfc underscore predict is something rfc underscore model dot predict, and we will provide the x underscore test. So you have this test as well. Now you can run the accuracy score. The same thing, that's what I've said earlier. Same thing you need to basically do. So y underscore test comma rfc underscore predict will give you your accuracy score. So what you get is 77%. Similarly, you may have got something here from SVM, and here in case of a logistic regression you got 79%. So still 79% is good as compared to this. However, you can modify its the number of parameters which is present here. That's a different topic altogether, but for now, since this is very basic, I want to keep it as it is and give you this output. One thing what you can do is you can basically identify the features which is which is providing importance. So if I go up, you will see find the variables that impact the most. So random forest classifier has this way where RFC model can basically give you the feature importance. RFC underscore model, feature underscore importance, and but you get output of this, which is something you cannot interpret. So let's visualize this, and this code you can keep it with you so that whenever needed you will going to you can visualize this. So we will use the panda series to convert the array into a series. So we have this pandas underscore series, and here we need to basically use the same thing, RFC underscore model dot feature underscore importance, there you go, and feature underscore importance. Here we need to provide the column name to each of these variables. So we will say index equals to x dot columns, right? Because x has columns. So this if you remember, I have given you this method earlier to get all the column names. And then we will use the plot method because it is pandas object, so we can use the plot object on this. And we will use the kind and par h, and this will visualize this output that will help you basically identify that this feature glucose is the highest one, which is contributing a lot compared with the BMI, then I think the age, then you have the diabetes. So these are the 4 or 5 basically parameters who are contributing a lot. Rest other is almost in a similar category, so I would highly focus at least on these first 2, and then after that maybe in those 2 to provide an input to my end user as to what are those variables which is influencing a lot, right? Similarly, after random forest, what you can do is you can basically get the decision tree as well as the so from sklearn.tree you have import decision tree classifier. Come on, yeah, there you go. Same thing you need to repeat like we have done it over here in case of logistic regression or in case of this random forest. Same thing you will do, and it will give you the output till here, right? And you can see whether this feature importance variable is present. I have not tested it, so you can basically see whether this gives you the feature importance and whether if this object is present there, then whether this is different from it. So something you can do this. Another is XGBoost. So the way you can get the XGBoost is it's a different library altogether. This is extreme gradient boosting. So it is XGBoost import XGB classifier. There you go, XGB classifier. And once you execute, you will again do the same thing. And I'm sure that I have run this in my work situation as well. So this thing is basically present there as well. So all of this information you will find it with the XGBoost as well. XGBoost also gives a very good result. So you can basically compare whether logistic regression is the best one or you are getting better result in decision tree or in XGB classifier, and whether the XGB classifier feature importance is similar to this one or not. That way your case study will be completed. You have created how many? 1, 2, 3, 4 and 5 different models, right? At least at a high level, you have got a good and strong idea as to how this end-to-end basically model will going to work when you will have to basically create like multiple models and produce the output, right? But in case if you need to test it with some external values, so I will just say 16, test the model with external values. So what I can do is I can basically take, let's say one of our external value is, let's say this one, right? So let me create a object over here which we will say, let's say test underscore data, and we will going to create this basically we can create np array, which is this np dot as array, and there we can say 8,183, 64, 0. I'm just trying it this, and let me see whether it gives the right value or not. 0, and after that you have 0, after that you have 23.3, 23.3 and 0.672, then you have 32. These are the only values, because after that the outcome is that person is diabetic. So let's execute this. Okay, takes 1 to 3 argument. Okay, let's do one more thing. Let's create test underscore data, and we will call it NP, and we will take this. I was just trying to directly do it, but no, I think that's how you need to basically convert this, right? And we will say test underscore data. So now we have this, and once we are done with this, so NP and test underscore data underscore NP is now present. So we can go down there. So we have created this logistic regression, right? So I will just create a couple of more rows. I'm just pressing A here. A basically creates a row above. It's a shortcut. So now we have this. Only thing we need to do is input underscore data underscore rs reshape. We have to reshape this data because what it accepts is the 2 dimension and we don't know the another dimension. So we use this technique which is commonly known once you are an experienced one, where we say input underscore data or np, not input but test. We'll say test. We'll just keep it consistent. Test data np dot reshape, and we should reshape to 1 comma -1. -1 basically let the system figure out what the additional dimension is. So we just execute that. It executes without any issue. If this will going to be an issue a little bit, you may need to read its documentation as to what it does. And even on the Stack Overflow, you will find a lot of good documentation over there in a very simple language. But in a simple way, what it does is it lets it identify the remaining structure of the NumPy array. That way you can specify it in your machine learning algorithm, which expects this, by the way. And with this, it just does the things automatically for you. All right. So once you have this, what we can do is test underscore predict, and we will say what is our model, log reg, right? So log reg dot predict, and within the predict we need to specify this test underscore data underscore rs, and we'll get the output. Okay, what do we get is an error or something. So user warning, X does not have a valid feature name, but logistic regression was fitted feature name X does not have any. All right, no problem. If this warning is coming, let me create one row. So I just come out of that. I will just click somewhere here and press A to create a row here, and we will get the output by printing this, or by just running test underscore predict, control enter, and it will give you 1. 1 will basically telling you, the output 1 is basically telling you that whatever value we have provided here, the person is diabetic, and that's what it was coming here, if you remember from this row. So that means the model, at least at a high level, working fine and giving you the output. But this is just the starting. It is not the ending. This is just the starting, and there is a lot that needs to be done after that. But if your basics are right, and if you are at least able to do this much of a work, at least you are, I would say, 60-65% through with your model, and then remaining 30-35% or sorry 35 to 40% is where you need to tune your parameter, you need to standardize your data, or you need to do some cross validation. All of these things which comes into the picture whenever we are doing this type of a modeling. But I hope you like this project, and I will in future I will put some more case studies like this together, and let me know if you have any more suggestions around the case studies. Also in description you will find the more case studies link. So keep following this, and I will be posting more and more case studies in coming days. With that, thank you so much for watching. I'll meet you in the next video with a new topic.